In the sciences, there are huge mistakes made, and sometimes we don't realize that they're mistakes hundreds of years after the fact, but I just happen to lucky to find one of the mistakes. Hi, Celeste. Now, William Mina Fleming was a Scottish astronomer active in the United States. She was alive from 1857 to 1911. So this is long before the fusion model of stars existed, long before advanced telescopes, really advanced telescopes existed, long before space telescopes, long before the vast majority of astronomers that live today even were even alive. She helped develop the common designation system for stars and cataloged thousands of stars and other astronomical phenomena. This is very important to understand. I want people to know that the mistakes that astronomy has made, these aren't relatively new things here. The mistakes that modern astronomers have accepted and still continue to make were made back in the 1800s. And we know this because this lady here, Fleming, was in charge of the Harvard College Observatory and cataloging stellar spectra. I'm going to read this out to you guys. And the first catalog was called the Henry Draper catalog. In 1886, Mary Anna Draper, the wealthy widow of astronomer Henry Draper, started the Henry Draper Memorial to fund the HCO, which is the Harvard College Observatory, HCO's research. In response, the HCO began work on the first Henry Draper catalog, a long-term project to obtain the optical spectra of as many stars as possible and to index and classify stars by spectra. Now, I talked about this in an earlier video. Classifying stars on their spectra is great. It's wonderful they did this kind of catalog. They could look at their spectra and they could determine what elements were in their spectrum and all that good stuff because they are bright and you could see them with the telescopes, and you could get pictures of them using these large telescopes and photographic materials. Only one problem. They assumed that all stars shined. If you want to classify as many stars as you can, the stars that have the spectra are only going to be the young ones. They're only going to be looking at the young stars because those are the stars that have the spectra, have that bright light that you can look at. And you can put a prism on it and separate the constituent electromagnetic spectrum. And it's very important to understand this because this is when it started. 1886 is when they started to say, well, only the stars that shine are actual stars. They never thought, well, maybe we're just looking at stars that shine and the majority of the stars no longer shine anymore. Therefore, they won't have spectra to classify. Therefore, a stellar catalog will be vastly incomplete. But they didn't look at it like that. Their completeness had to do with how many of the objects that they could see could be classified. For instance, if they couldn't see it, then it didn't matter. It was off the radar, so to speak. It was not important. It's not valuable information because obviously there's no information to gather if you can't see anything. It would just be hypotheticals way back in the 1800s. And looking at this graph, we can see the Henry Draper catalog back in the 1800s when these individuals were classifying stars based on their spectra. We're only the stars right over here. And mostly, they weren't even mostly red dwarfs. They were mostly like orange dwarfs and all the way up. Because they're really bright and really hot, and you could see them. And as time progressed, our telescopes got better and better. And then we started to realize the younger stars were up here. But we started to realize that there are more and more stars the further and the dimmer and dimmer that you got. And we can see that in the Harvard classification system. So you have the O, B, A, F, G, K, M stars. So here's a little printout for you. The really young stars on the very, very left-hand side, the O's, the B's, the A's, F's, G's, K's, and the M's. And notice 2400 degrees Kelvin, and it stops. What if you find a star that's 2399 Kelvin or 2398 Kelvin? Just 1 to 2 degrees Kelvin difference. Doesn't matter. It's not a star because it doesn't have a spectrum. But in this theory, we know better. They're all stars. They all have spectrums when they're young. Bright, hot, shining spectrums. And these are the objects people in the 1800s were classifying. And then the 1900s rolled around, early 1900s. And then the 1950s, 1980s rolled around, we found brown dwarfs. 1990s, first exoplanets, the big hot Jupiters. And then 2000s and 2020s. And we work our way down the line, we realize that there's a lot more out there than what meets the eye. We're realizing slowly but surely that these objects are all the same. The young ones have spectra, shine, and the old ones don't. And it should be a challenge for a lot of astronomers to realize this. Well, for rightful reasons. I mean, this information has been accepted for over 100 years. It's going to take a lot of pressure for them to change. But the pattern, it's all there. They cool down. They start blue and white, and they move more towards the red spectrum, and eventually they become brownish, and then they dim completely. You can't see them because they're called planets. Where's the next one? Their mass changes. See their mass right there? Their mass diminishes considerably. They lose all their mass. Their radius shrinks significantly, which means they become smaller. Their luminosity changes. That's the obvious one here. The bolometric luminosity. They're really, really bright, and they dim considerably to where you can't see them anymore. And the hydrogen lines change because the hydrogen is all lost. All the lighter elements are lost, the heavier elements remain. Because they're heavy, they sink to the center of the star, forming the planet. And the most interesting one of all is the fraction of all stars. They say main sequence. I would ignore that. That's not science. That's pseudoscience. You have the really, really bright, young, hot stars. Very, very, very few of them. Fraction, the percentage, 0.00003. And then the fraction percentage goes up as you move down the line. And they say here that red dwarfs, or M stars, are 2400, 3700 degrees Kelvin. The fraction of them that exists is 76.45%. So 3/4 of all stars that they observe are red dwarfs. Well, little do they know, that's sorely mistaken. They're still classifying stars as being right there. But there's going to be a hell of a lot more brown dwarfs. There's going to be even more Jupiter-sized objects, even more gray dwarfs, even more Neptune-sized objects, and even more ocean worlds, and even more Earths. And that's a conclusion I don't think they're willing to accept yet. I think it sort of scares them a little bit, but I'm not going to go into that. All right, you guys, I think that's it. Just make sure that when you look at scientific articles, realize that a lot of the ideas that they've accepted were created long, long before they had all the information available, and it's severely outdated. Did that rhyme? Okay, anyways. All right, later, y'all.